Thank you. Hello, everybody. Shop Direct is an online retailer with a long-standing, loyal customer base. The questions we are asking as a company are, how do we reach our customers better? How do we understand and identify when somebody is leaving us? And how do we bring them back? Ultimately, what motivates customers to shop with us? I'm Simon Hill. I'm a lead data scientist at Shop Direct, and I'm excited to be here today to talk around Shop Direct itself, the transformation journey that the business is going on, and the part in which data science plays. I'm then going to go into a little bit more detail around one of the key challenges we are currently working on, how to reinvent customer communication strategy for a purely online world. For those of you who don't know, Shop Direct is the second largest pure-play online retailer in the UK. We trade with our customers across 3 brands: Littlewoods, Very, and Very Exclusive. Shop Direct offers its customers a wide variety of own-brand home, fashion, and electrical product, as well as such world-renowned brands such as Ted Baker, Nike, Apple, and Samsung. Last year, we generated sales of £1.86 billion and currently have 4 million active customers. Shop Direct is also an organisation that is mobile first, driven largely by the preferences of our customers. 68% of our sales last year were transacted via mobile devices. Shop Direct has a long history of innovation, from the earliest pioneering days of bricks and mortar retail and catalogues, combined with easy payment terms accessible to all. We have also embraced technology where appropriate, offering our customers telephone shopping facilities in the 1970s and progressing to our first transactional website in the late 1990s. More recently, we have launched our luxury brand, Very Exclusive. And this takes desirable product and applies Shop Direct's affordable credit proposition to make accessible luxury items available to all. We also have a long history of using advanced analytics and predictive modelling in areas such as credit decisioning, targeting of outbound marketing communications, and personalisation and product recommendations. Our data science team is currently growing rapidly and collaborates with a lot of different areas across the organisation. For example, we are currently working with our online marketing colleagues to apply advanced algorithms and machine learning to optimise the content shown to our customers on their homepage, and also recommend and sort product that is returned via our internal search. We are working with our financial services colleagues to apply advanced decisioning and machine learning to present appropriate and suitable payment methods and options when the customer tries to place a purchase with us. We are working with our marketing and finance colleagues to use predictive models to understand the future value of our customers and identify which of those customers we want to focus on. Last but not least, we are working with our product colleagues as well to better understand the price elasticity and to ultimately optimize our pricing to help generate a more effective pricing strategy for the organization. As well as our collaborative pieces, we are also trying to move into more of an experimental state, investigating areas such as artificial intelligence within the space of chatbots, and also using advanced image recognition to start creating more automated product attribution to further help our recommendation engines. A very big area that we collaborate with is with our colleagues in the customer relationship management area. And this is a really interesting area with many challenges for a data science team to really get its teeth stuck into. For example, how do we take our new customers and turn them into high-value ones? And then how do we take that learning and use it to try and identify and obtain more of the right customers in the first place? How can we optimize our outbound marketing communications, taking into account the way that customers interact with our website and take into account the specifics of their behavior? What are the motivations and drivers of our highest value customers? And how do we use that information to serve their needs better? And lastly, how do we identify customers who are lapsing? How do we develop strategies to bring them back? And ultimately, how do we make fewer people move into this space in the first place? And this is the area I want to spend a little bit more time speaking about this afternoon. Shop Direct, in common with most retailers, has always been really interested in customer attrition. It currently costs us around £100 to acquire a new customer, so it is very important that we actually retain the ones we already have. Traditionally, this would have been done through a combination of big book catalogues and direct mail. Every 6 months, our customers would receive a 1,200-page catalogue containing the latest and greatest product across home, electricals and fashion. For many of our customers, this would have been enough to encourage them to place an order, but some of our customers would need a little bit more of a nudge. For those customers, we would send them a direct mail communication around 8 weeks after the catalogue with a discount offer to try and encourage them to open their catalogue again and place an order. If this was unsuccessful, we would then add in 2 further communications with increasing offer strength. Again, this is just designed to get the customer to reopen their catalogue and try and place an order. Once a customer had ordered, they would be included in our subsequent season's catalogue mailing process, and then the cycle would begin again. The main challenge we had with this is that it was based around a fairly arbitrary business calendar, based ultimately around the distribution of the book and the need to drive an order to send the customer the next one. Similarly, some of our highest value customers and our most long-standing customers started to understand our promotional calendar and promotional frequency and started to wait to receive the larger discounts before they would shop in the first place. This obviously is somewhat counterproductive for the organisation, as it costs us more money than we necessarily need to spend to get a customer to place an order. Despite these challenges, this strategy worked very effectively for many years. However, with the rise of web and mobile, the space for our traditional marketing activity started to reduce. As more and more customers came to the site organically, they were being exposed to our promotional and marketing messages without necessarily being targeted for them. This meant that our traditional activity had little space over the top to generate additional sales, and ultimately led to one very high-profile casualty, that of our catalogue itself, which we removed from the business in 2015. Once the catalogue had been removed, the rationale for our contact strategy that fed off the back of it also went away, creating an opportunity for us to make a more customer-centric approach to the way that we targeted our customers. But what could this program look like? How do we take customer data and customer interactions into account in determining which of our customers are lapsing and which ones we need to reactivate? And this is the problem that data science are attempting to solve. In order to understand how to build a better lapsing customer journey and lapsing customer program, we identified 3 key questions we needed to answer. Who to contact, and this also includes trying to understand which of our customers we may not want to contact, as not all customers are created equal. When do we want to contact them? How can we identify customers who are lapsing, and at what point in their journey do we want to intervene? And ultimately, how often do we want to contact them once we have decided to? The third question is, what should we contact them with? Currently, our focus here is largely around discount messaging, but there are plans afoot to incorporate product and financial services messaging in here as well, to try and increase the relevancy of our communications. In order to answer these 3 questions, we have built 4 models and solutions. The first of this is to understand who we should contact, and in this case, this is a simple recency frequency value segmentation. Now, RFV segmentations are hardly cutting-edge data science, but there is a little bit more sophistication here than meets the eye. Our recency axis is just as simple as that seems. It is just a view of when the customer last placed an order with us. Our value axis, though, instead of being a measure of sales over a certain time period, is actually a detailed profitability calculation, taking into account the margin of the products that a customer purchases, the true cost of delivery and fulfillment of their orders, and financial services variables such as interest payments and warranty sales. Our frequency axis is actually a simple measure of customer engagement, taking into account the departments a customer shops in and also starting to categorize visit data between intent and non-intent sessions. These three variables are combined using principal component analysis to distill the information down into a single engagement score. Having created our three axes, we have built a grid of 60 segments, which can then be used on their own or grouped together into higher level clusters for easier management. The advantage of a mechanism such as this is that it is a simple framework from which we can hang some more sophisticated models and solutions on top of. It also has significant advantages for business stakeholders in that it is easy to explain, and in the early stages of this project was very important in order for us to get our stakeholders bought into the program. Having identified who we want to talk to, the next question is when should we talk to them? And for this we have built two specific solutions. The first of these is a very simple view of the average time between customers' orders. Here, the simple approach allows us to get an overview of a customer's underlying ordering pattern, and then which can be used to create a baseline. We can then look to see easily when a customer starts to deviate from this path. However, this is quite simple. So this on its own is not enough for us to intervene. And this is where the second model comes in, our incremental ordering model. This model works from the perspective that our most valuable and highest engaged customers tend to be the ones who are least responsive to marketing, as these customers will shop anyway. The trick here, therefore, is for us to identify the customers whose likelihood to shop will increase the most through the act of contacting them. In order to do this, we have taken the mailed customers from a series of different campaigns and also identified the equivalent control groups of people who did not receive the campaign from that selection. We have then collected demographic, account and transactional information for each campaign in order to start understanding which factors will generate the biggest difference in terms of response between the customers who received the campaigns and their random control groups who did not. In this space, we have used weights of evidence to calculate the differences. And this will give having calculated the weights of evidence for our various different variables, we have identified a candidate list of data that we can then use to help further improve our model. Candidate list, though, is not enough on its own. We need to check for effect stability, as it is no good that if effects in one space show that are not stable when we try to apply to another data set. Effectively, if the effects break down, they're not really much use to us, and it's much better for us to have a weaker effect that shows stability across multiple data sets than a stronger one, which is extremely variable. In order to do this, we have recalculated the weights of evidence on a second data sample. And where the effects are showing some instability, I've calculated a penalisation factor, which we then apply back to the results from the first sample. This now gives us a re-ranked list based on information value. But even here, we still need to do some further work. A lot of the data we've collected is still highly correlated. So we have a further variable reduction process using variable clustering techniques to identify correlated variables and then just select the single variable from each cluster with the highest information value. Once identified, we're down to a final candidate list for our model, at which point we've built a logistic regression model on both the mailed and controlled customers. These two models are then scored out on our entire customer base, and the customers with the biggest difference between mailed model score and control model score are the ones that we are targeting for future activity. Having identified who we want to contact and when to contact them, the final question is what we want to contact them with. Traditionally, Shop Direct has used pounds and percentage discounts to try and reactivate customers. However, when we started to dig into this data, we realized very quickly that we had another challenge. Our traditional approach largely uses each type of voucher for very different reasons. So there are large areas of our customer base where we are missing data for the effectiveness of one type of voucher or another. In order to fill this knowledge gap, we proposed and executed an entirely random offer test. We identified 250,000 customers from our mailing file and split them down into 10 groups. Each group then received one of our portfolio of pounds and percentage discounts, and to generate a data set to allow us to understand both the effectiveness of each individual voucher and start to drill into the impacts of the different voucher types on different customer profiles and segments. This test was a real watershed for Shop Direct, in that it was the first test that we have executed whose primary focus was to generate data for future modelling, as opposed to a purely commercial outcome. Sending random offers to random customers tends to be quite a costly endeavour, so it's a testament to the importance of this project that we were able to land this test to help us further improve our models. We now have 4 models and solutions to help us answer our 3 key questions. A segmentation to understand the value and engagement of our customers to identify who we are interested in contacting. A model to understand the basic underlying ordering pattern of a customer. A model that predicts who is likely to be responsive to an individual communication. And a data set to enable us to understand which offer we should be putting in front of customers. The final step, therefore, is to put these 4 factors together. Initially, we took our segment data and overlaid the results of our random offer test to try and understand the sweet spot for each segment as to which was the most appropriate offer to put in front of somebody. The aim here was to identify offers that a customer would be responsive to without putting too big an incentive in front of them to help us manage cost. Having identified the initial offer view, we have then applied the 2 offer models, looking to identify cut-offs to determine which of the customers should be included at any particular point in time. This approach involved scenario analysis. We ran dozens of iterations to understand the impacts of our decisions across our key business KPIs, including ordering rates, incremental sales, and ultimately incremental profit. Having identified our initial optimum combination, we then built a decision logic which ties these 4 models together, which we then have scheduled and runs every fortnight. Every fortnight, a customer will be evaluated to see which segment they are in. We will run the ordering models to determine whether or not we should be contacting at this point in time, and then the random offer data will identifies which of the offers we should be putting in front of the customers, taking into account the offers we've made previously. As at this point, we want to make sure that a customer receives a different offer than the one they had previously received. This approach has been running now successfully for around a year, but in that time we've been further refining our models to try and improve performance. The modular nature of the decision flow we have built means that we can easily swap in and out challenger models to further improve the performance of our system, and that's exactly what we've been doing. Our initial focus has been looking to try and challenge the data we are using around customers' individual ordering patterns. For example, if we know that a customer orders every 4 weeks, is that literally every 4 weeks? Or is it more likely to be 13 orders in a year, spaced relatively randomly? As such, how do we bring in seasonal effects and other information that may affect exactly how frequently a customer will shop with us? In order to do this, we have started to revisit our initial view of customer engagement. This takes the engagement data we have built and applied within our segmentation, using the departments that a customer shops in, and also the visit data, and adds in further granular detail around the way that customers are interacting with us on site, their shopping behaviour at a more granular level within our product hierarchy, the channel that a customer is interacting us with, so how are they actually reaching our site, how are they interacting with Shop Direct's credit proposition, how much credit do they have available, how are they using it, What device are they using to shop with us? Is it desktop, mobile, or tablet? And are they displaying behaviours around basket abandonment and repeat browsing? This data is then, again, has been distilled down using principal component analysis, once again to provide a new engagement score for use in future models. In this case, we have also added in a decay factor, as we want to make sure that the most recent information is being weighted most heavily, so that we can truly understand exactly how a customer is interacting with us and take into account their most recent interactions. Having built the engagement score, we are then incorporating this into a new model framework using survival analysis. As well as the engagement score, we have added in the number and type of orders that the customer is placing, sales data, and credit behaviour. Currently, our system produces 125,000 individual curves and are designed to give a measure of when how likely an individual customer is to have ordered at any point in time after their previous one. We have also added in a self-calibration, self-learning element to this approach to make sure that these models will accurately reflect the underlying nature of our business and remain predictive into the future. Having built these models, we've then run the same process as previously, running scenario analyses against individual cut-offs across the model spectrum to identify the most appropriate place to be cutting off. Once this has been done, this model has been slotted into our decision flow in place of the ordering pattern data that we've previously used, and this approach is currently under test. In addition to this, we have also been looking into further understanding around our offer strategy. And in particular, we are trying to now start to understand the effects of memory on our customers' behaviour. For example, do our customers have a memory of vouchers like an elephant or like a goldfish? Do we actually need to vary the offers that we put in front of them? Does this matter at all? Do we need to always increase them? Could we get away with simply changing the offers that we place in front of our customers? In order to do this, we have taken our random offer test and have extended it, identifying a very small proportion of our customer base who will be continually contacted with various different random offers. In some cases, the offer may be bigger than previous. In other cases, it may be smaller. In some cases, it may be no offer at all. The aim here, though, is for us to build a data set that we can start to use to more accurately optimize the offer strategy for each customer and customer segments. That brings me to the end. It's been a fairly whistle-stop tour of the work that we've been doing on our Lapsing Challenger program. Really, I just wanted to finish off by talking about where we're heading next. Earlier on, I mentioned that we had 3 key questions that we were looking to answer: who to contact, when to contact them, and what to contact them with. We're now looking to add 2 further questions into the mix: how to contact a customer. At the moment, our most effective channel is direct mail, which creates a challenge for us in terms of, as direct mail is both slow and costly. It's difficult to be responsive to customers' individual on-site behaviour if you are operating in a direct mail channel where the lead time to produce and distribute a communication is 2 weeks. As such, there are big benefits for us if we can identify a set of customers who would be just as responsive to digital channels such as email, SMS, and push. The 5th question we're looking to answer is the one that's potentially the most exciting one of all. It is, why does somebody shop with us? And more especially, why does somebody stop shopping with us? There are many different factors that may affect whether a customer is ultimately lapsing with us that are not necessarily immediately noticeable within their ordering behaviour. For example, they may have had a poor delivery experience or received a faulty product, which discourages the customer from coming back again. External factors: the customer may have moved house, which changes the types of products they're interested in, moving them from products that have a fairly high turnover to something that is bought less frequently. If we can identify the drivers of why people shop with us and why people are stopping shopping with us, we can incorporate these messages into our communications and make them more personalised, targeted and relevant for our customers. We are also looking to incorporate additional messages around product and financial services in our communications. For customers in the early stages of lapsing, there is an argument that if we can identify the right product messaging, recommended products, new in items, high sellers, we may be able to, again, reduce our reliance on discount messaging and move to things that are more timely and relevant for individual customers. Ultimately, though, this is just one small step on our much larger journey. A journey to build an advanced system using advanced algorithms and machine learning to personalise our communications, understanding who we want to contact, which message or messages we want to put in front of our customers, when to contact them, and how best to reach them. This brings me to the end of my talk for this afternoon. Thank you for listening, and I'm happy to take any questions you may have.
Thank you very much. Very interesting, and Shop Direct have obviously moved a long way over the last decade. I'd just like to add a suggestion. You said that email had advantages. What you can do with email is embed cookies to find out actually what did the customer look for on that email. And a lot of companies embed a cookie just to say, has the customer opened the email?
Yeah.
Thanks very much for that talk. I was just thinking about your order frequency.
Mm-hmm.
If you have a customer where their order frequency is low, it's only going to go down until they purchase again, and that could be they only buy at Christmas. So that could be 12 months. How do you deal with that? Do you say, I'm not going to make a call on this customer's frequency until a certain time has elapsed, or do you try and model what their frequency will be?
So at the moment, what we're doing is that once a customer has gone beyond a certain point between since their last order, they will automatically be included in the contacts, regardless of of whether or not they're passing some of the other entry criteria. At the moment, that's running at about 6 months. The seasonal shopper issue is quite a challenging one for us. So it's it's a fine line between, if somebody only shops at Christmas, do you leave them alone over the course of the rest of the year, or do you try and re-stimulate them? And at the moment, our strategy is, to a point, yes, we want to try and ultimately we want to try and increase the number of orders that a customer places, regardless of whether or not they are lapsing in the strictest sense.
Hi, thank you very much for the talk. Yes, it's all well and good to have a good strategy to engage with customers and bring that to the higher level. That's excellent. I would like to bring your attention towards the checkout of a product, let's say. For example, I don't know whether you know this or not, but for example, let's say if a customer buys a pair of shoes, right? Okay. Now, on the stock levels on the checkout, it says, okay, yes, they are available, yes, more than 10 or whatever. But then, if the customer checks out, but if it transpires that no, actually the shoes are actually out of stock, but the only problem is the actual stock level ticker on the actual website is out of date and it's not really in real time with your backend warehouse system.
Mm-hmm.
So I think that needs to be resolved, not just for you, but I mean in general for the online retail market. What do you think about that?
So real-time stock data is obviously really important, because that plays into the space of why somebody stop shopping with you. If you ultimately, if you disappoint your customer because you have products that are out of stock, that's going to be one of the kind of factors that affects whether somebody comes back to you, and it's one of the areas we're looking to really tap into, is understanding the sort of potential service-led issues of that nature, and then trying to address that within our messaging, and trying to address it before it becomes a problem in the future.
Hey, it was a great talk. Can you tell me a bit about how you perform these experiments in your system? So is it a manual process you perform a certain period of times, or it's an automatic?
So at the moment, we work quite closely with a team of data engineers who take the models that we've built. The models then will run daily or weekly, depending on the frequency of update, and that gets produced into a data set that we then pass on to our colleagues who execute the campaigns. In each case, so each of our individual communications will have a mailed group and a non-mailed control, which will have been selected randomly from the same population. We've also got a longer-term sort of control monitoring strategy in place. So a set of customers who are going through this program, and it will either be triggered in or not, depending on their behaviour. A set of customers who are receiving the champion approach, and also a non-mailed control group.
Do you extract these data manually?
So at the moment the extraction is manually, yeah. So it's running through IBM Campaign.
Yeah, you mentioned in the value as part of the RFM segmentation, the effective margin. Is that something that's important in the overall model, the margins of different products and how customers respond to it?
It's very important to us, yeah. Because we have such a wide array of products that we sell, and we're ranging from some of our own brand fashion lines, which have an extremely high margin, through to some of the biggest brands we sell, so things like Apple, for example, are very low margin. Generally speaking, the higher margin stuff tends to be the cheaper end of the spectrum, and the things that we generate a lot of volume through and a lot of frequency. The lower margin pieces are the higher ticket, but it's important for us to understand exactly how our customers are behaving, because the spectrum is so wide.
Thank you for your talk. It's a great talk, and I have two questions, hope you don't mind. And the first question is on your presentation, you combined a few models together to generate a final, I assume something like a score or similar. And there's two opposite arguments that sometimes you need to focus on high score customer, high probability to buy your product, something like that. The other argument is you may probably target those customers slightly lower, relatively lower score, because those high score customers will buy your product anyway, but those relative low score may have the potential if you do the promotions. So what do you consider this, or what do you think about this?
So that's exactly what we're trying to do with the incremental ordering model. And by and large, we're targeting the customers with the relatively low propensity to shop, whose propensity increases the most when we actually target them with the communications. Otherwise, we end up sending out our communications across all of our various channels to the people who we're not really seeing much of an incremental return from.
Okay, and so you have a few different scores, and then by then selects sort of combination of scores, or.
So yeah, so it is that we only have one model that is doing that specific job, but it's part of the decisioning process. Effectively, it's that model is applied after we've identified that a customer is in a segment that we want to contact. We will then apply a model to determine whether or not we think they're going to be responsive to a contact, and then look to then check to see how they are operating against their ordering pattern to deter. And it's those three pieces together that determines whether or not we actually contact somebody or not. But somebody who is within their normal ordering pattern, we don't think is responsive to a contact, we won't send them one.
Thanks. And the second question is, I remember you mentioned a few techniques like PCA, principal components analysis, if I didn't misunderstand. And the other one is you use for variable clustering, right? So in one scenario, you use variables clustering. Based on what I understand, you're trying to, a lot of variables are high correlated with each other. You were trying to remove those collinear array, right?
Yeah.
So you cluster those variables, select one variable in each cluster. So why you don't use principal components or both to test which is?
So that was just a decision that we made, was to go down the variable clustering approach. That element of the process was something that we needed to turn around fairly quickly. So we weren't really in the position of having the luxury of being able to investigate multiple options at that point.
Yeah, the reason I asked this is because sometimes I find out, personally, sometimes you remove too many variables, could lose quite a few information. Some of the variable may be just noise, but sometimes you lose a lot of information. So that's why I ask which is the best way to do it. Thanks.
Right, last question.
Thank you. I'm quite happy when you mentioned about survival analysis. So I just have an interest on how do you apply survival analysis to helping your campaign? So when you have the curve, then I suppose you also look at the hybrid functions, right? And how do you use this function to help your campaign? Could you tell me a bit more?
So what we're actually trying to do there is to identify the survival curves. Essentially are built upon on a combination of many customers. So effectively, they're micro segments. The way we're currently applying them is if the overall curve has a probability of an 80% likelihood to respond over a year time frame, we are currently using a cutoff of at what point would half of that population have ordered to try and create some kind of structure around the cutoff implementation. So effectively, we're trying to get to the point of saying, at what point do we think most people like this will have ordered, and beyond, if somebody has drifted beyond that point, that's when we'll start to intervene.
Basically, the idea of hybrid function, you basically the derivative of your survival function, then you get the hybrid function. That's exactly what you're talking about. You want to identify the likelihood of a person to purchase at let's say on day 5 or a week after.
Yeah, so the models are being scored out on an individual customer basis. So we've always got that view of when they last ordered. So how far along the curve that the customers are at any particular point in time.
Right, so thank you, Simon, again for the talk. Thank you also, everyone, for coming today. There's another talk in each of the other 2 rooms, and otherwise, see you next year or at the May meetup or at any other one. Bye.